Mr. Doolin, I thank you so much for tuning in. What we're going to do today is we're going to take a look at solutions and just give some introductory terms to the types of things that we're going to be dealing with in solutions. Some of the terms sound relatively similar to each other, so we've got to make sure that we differentiate these things right from the get-go so that when we describe things and when I describe things in class, you'll be able to understand and keep up with what exactly I mean because you've got the vocabulary down. So at the beginning, this is just going to be a vocabulary lesson, and I really need to make sure that you get the vocabulary down. So the first thing that we're going to do is we're actually going to describe what a solution is. All right? So a solution is a homogeneous mixture of two or more substances in a single phase. So a solution is a homogeneous mixture of two or more substances in a single phase. And again, I'm not writing that there, ladies and gentlemen, but you definitely 100% should be. Now, my solutions that we're going to deal with, those can actually exist either in a liquid or aqueous phase, right? And so we've got liquid, aqueous phase, and it can also, my solutions can also be in gas phase as well. Anything that has a flow to it, and actually liquid would be wrong because a liquid is a pure substance. It doesn't even represent a mixture. So I'm either looking at aqueous or gas phases here for my solutions. And remember, if you think back, aqueous is just something that is dissolved in a water, right? Okay, and so I've got solution down. Now, what are the different parts of a solution? Well, I've got two different parts of a solution. I've got either a solute or a solvent. Now, a solute is the substance that is being dissolved. Now, a lot of times you're going to think of that as being your solid substance, but keep an open mind, it's the substance that is being dissolved. My solvent is generally the substance that my solute is dissolving into. All right? And so my solvent is the substance that my solute is dissolving into. And then the very last term that we're going to get to define, and I'm actually going to go ahead and clear the page here, is actually a term known as solubility. And so solubility is the maximum amount of a solute that will dissolve in 100 grams of water at any given temperature. And so again, solubility is the maximum amount of solute that will dissolve in 100 grams of water at any given temperature. And what we do is we end up with a solubility curve. And so my solubility curve, I'm going to go ahead and take a second and pause here and draw it. Okay, and so what I've got there is a solubility curve, and again, we talked about grams of solute per 100 grams of water. That's what solubility actually is, and it's at any given temperature. So this is a solubility curve. It's solubility versus temperature. And what I'm going to do is I'm just going to go ahead and put some different substances on here. First thing that we're going to look at is sugar. Well, sugar is relatively soluble, and so what we do is we see a curve like this, right? And so one thing that you'll notice is that as temperature increases, so does the amount of sugar that will dissolve. And so we'll talk about that in just a little bit. All right? Second thing I'm going to do is I'll start with, what is this? Sodium nitrate. So sodium nitrate will look like so. And these are all approximate. All right? So there's my sodium nitrate. Potassium nitrate, we'll draw that in green. It starts way down here. But this sucker goes there. And so that is potassium nitrate, which is KNO3. All right, and then I've got sodium bromide, which is just a little bit different here, and it's going to flatten out and be in a BR. And so what you'll see here, and don't overthink it, ladies and gentlemen, is as I'm running across this line, what that's telling me, if I just go up at 60 degrees, about 110 or 120 grams of that substance will dissolve. And so if I'm running on the line, it's really important to understand that the line equals the maximum, right? So the line represents this maximum amount that will dissolve at that particular temperature. And make sure that you get that down, ladies and gentlemen. The line equals the maximum amount of dissolved substance at that temperature, all right? And what we're going to do is we're going to go ahead and coin a phrase here that this is what we're going to know as a saturated let me go ahead and make sure I spell that correctly for you there. Saturated solution. And so if it's on the line, it has the maximum amount dissolved, that is known as a saturated solution. Well, I got a couple of different things I can do. What if I'm looking at, I'm going to use sodium bromide here at 80 degrees. What if I'm way up here, right? I've got more dissolved than should be dissolved, and so what do I call that? Well, if I'm above the line, right, I've actually got too much dissolved, right? And what we do is what we call that is I am now super saturated, right? I've got too much dissolved. And the way that we make a supersaturated solution, because a lot of you right now are scratching your head like, well, wait a minute, Mr. Dillon, you just said the line was the maximum. Now you're telling me I can go over the maximum? Well, let's take a look for a second here, and let's use sodium nitrate as my example. So I'm looking at the orange line here. Notice at 60 degrees, I'll run down at 60 degrees, I'll run over, and I can get about 200 grams dissolved. Well, what happens if I heat this substance up or heat my solution up to 60 degrees? I can dissolve 200 grams of sodium nitrate, but then I just set it on the countertop and I let it cool back down to room temperature. Well, at room temperature, I'm right around 20 degrees, and I should only have about, let's say, 185-ish grams dissolved. Well, I've got way too much. Right? I'm sorry, that's 85, right? I've got way too much dissolved, and so what happens is I would actually be right here at that particular temperature, and so I'd have that much too much that is dissolved, right? And so what we do is we call that a supersaturated solution, and we'll talk a little bit more about that in just a second, all right? And then the last one that we can deal with is actually below the line, right? And here, all we're going to say is more will dissolve, right? And so if I'm below the line, more will dissolve, and you guessed it, we do have a term to describe that, and this particular term is known as unsaturated. And so the three terms that you'll need to know here, saturated, supersaturated, and unsaturated, you'll need to be able to read the solubility curve and just understand that line represents that maximum, and I can be supersaturated or I can be unsaturated. It also really helps, ladies and gentlemen, if you understand how something becomes supersaturated. And just understand for these particular substances, and these all represent, by the way, these all represent solids. This is a solubility curve of a solid, all right? Now, for reasons that I'm not going to explain just yet, I'm going to go ahead and tell you that gases are going to be my purple line here, and a gas would look something like this, right? So notice my gas solubility decreases as temperatures go up. It's opposite of what solids do. Make a big note and highlight that in your notes, because that's something, again, we're going to address as we move further and deeper into the understanding of what solutions and what's going on at the molecular level. All right, and so now what we're going to do is we're actually going to discuss a saturated solution. And the one thing I definitely want to talk to you now about saturated solution is a saturated solution represents a dynamic equilibrium situation. And what I mean by that is it actually goes forward and reverse. And so here we go. Let's explain everything about that. So I've got a solid down at the bottom of this water. Well, we understand that some of the solute molecules will actually dissolve. So this is my solute. And so if I wanted to represent this equation, I would put solute as a solid is actually becoming solute as aqueous, right? I've got solid dissolving in water, is what we're telling me there. So once I hit a saturated point, my question to you is any more actually dissolving, right? Is any more, once I'm saturated, is any more of that solid actually going to dissolve? Well, again, go back to dynamic equilibrium. I said we have a dynamic equilibrium. There's both a forward and a reverse. It's a balance, right? And so if we think of this particular reaction as being in a forward direction, but then also understand that there is a reverse direction, then we begin to see exactly what's going on at the molecular level. So the answer to the question, is any more dissolving, is an emphatic yes. Yes, there is more dissolving, even when I'm saturated, and that saturated represents that equilibrium situation. And so what we would say is some of the solute actually precipitates, and some of the solid actually dissolves, right? So I've got both the forward and the reverse occurring at the same time, but the key here is that both happen at the same rate, so we actually don't see a net change. But it's very important to start making this connection that in this particular equation, going from a solid to aqueous, I have forward and I have reverse, and even in a saturated solution where this equilibrium exists, both are occurring, but they're occurring at the same rate, so we don't see that net change. All right? All right, and the very last thing that we're going to touch on here, ladies and gentlemen, is supersaturated solutions. I told you we were going to come back to that, and so if I can spell crystals here. And so what we need to understand about supersaturated solutions is this is how we actually make crystals, all right? And so if I'm going to go ahead and tell you here and give you a scenario and say my saturated solution, I should get 50 grams per 100 grams of H2O, all right? And so this would be on the line. This would represent my dynamic equilibrium, and this would be my saturated solution. So again, I heat it up, dissolve more, and then cool it back down so that I end up with 75 grams actually dissolved. And so the question becomes, does all 75 grams want to actually be dissolved? Because this would be a supersaturated solution. And so what actually begins to happen is, as long as I get a nucleation site, right? And so I'm just going to go ahead and write that as nucleation. And all nucleation is it's the beginning seed. It's what starts a process, and then the process rolls downhill. So think of in the cartoons where one of the cartoon characters drops a little pebble on the side of a snowy mountain, and then the snowball just gets bigger and bigger and bigger and bigger and bigger. That's essentially what we're talking about with nucleation. We will start it, and then it will occur and just grow and build on itself. Right? And so nucleation will initiate that crystallization. And so when does it stop crystallizing? Well, a maximum of 50 grams can actually be dissolved in the solution. And so from a 75 grams dissolved for this particular substance, I would expect to get a 25 gram crystal recovered. All right? And so understand, if I'm supersaturated, the solution will not necessarily want to hold that. It's not stable to hold that much substance dissolved, and so if any nucleation occurs, I will get a crystal formation and I will precipitate out, and then some of it will end up dissolving back out to that saturated dynamic equilibrium, okay? All right, ladies and gentlemen, that was a lot. That was a whole lot. So if you got questions, get them down. I'll see you in tutorials for those. Otherwise, I'll see you in class.